Okay, so there are three rules we're going to discuss for how we would derive our equilibrium constant for coupled reactions. So our first rule states that changing the direction of a chemical equation basically swaps the reactants and products, right? So going in the forward direction where we have reactants A forming product B, if we change the direction, our reactant becomes B and our product becomes A. So this is our equilibrium constant expression in the forward direction. In the reverse, right, we go from B to A, and so our equilibrium constant would be the concentration of A over B. And we denote the reverse or the equilibrium constant for the reverse direction is Kc prime. So the general formula that we would use for an equilibrium constant of a reverse reaction is it's going to be 1 over the equilibrium constant expression of the forward reaction. All right, so our second rule has to do with changing the stoichiometric coefficients. So if we change it by some factor, we see this change in the exponential change in the equilibrium constant by that same factor. So if we change our original reaction A to B and we add some stoichiometric coefficients, it will be reflected in the equilibrium constant by raising our, it'll be reflected in the exponents, basically, right? So whatever factor that the stoichiometric coefficients are changed by will be reflected in the exponential change. So Kc prime here is the same as what our equilibrium constant Kc is, but raised to the factors of our stoichiometric coefficients. So Kc prime here is basically equal to whatever our equilibrium constant is raised to that factor x. Okay, so our final rule has to do with adding two or more equilibrium equations together. So they will yield an overall equation whose equilibrium constant K will be the product of each individual reaction's K values. So here are two equilibrium equations that we're adding together, A to B plus B to C. And we have our equilibrium constant for each of these reactions here, represented by Kc1 and Kc2. Now, when we add these reactions together, we get A plus B yields B plus C. B cancels out because it's on our reactant and product side, and we basically get an overall equation of A to C. So, according to this rule, our equilibrium constant for our overall reaction will be the product of each of the individual K values. So we multiply Kc1 by Kc2 and we get C over A as expected, right? So our general rule is Kc prime will be equal to the product, right, of our individual reaction K values.